Problem 10. One sunny day, Ling decided to take a hike in the mountains. She left her house at 8 p.m., drove at a constant speed of 45 miles per hour, and arrived at the hiking trail at 10 a.m. After hiking for 3 hours, Ling drove home at a constant speed of 60 miles per hour, which of the following graphs best represents the distance between Ling's car and her house over the course of her trip. So notice that at the very end, everything ends up at 0, meaning that the displacement is 0. Now, this is kind of more of a physics question than a math question, because it's asking you to understand how to graph velocity and distance together. So in this case, what is distance traveled? Distance traveled, let's say from point A to point B. If I were to make a round trip, A to B to A, this is considered, a standard route. But within this route, there's both distance and displacement. The distance traveled is equal to the length of AB times 2, right? Because it traveled A, B, then B, and A. But the displacement is basically how far away did I go from this point of origin. So I started at A. At the very end, how far away did I get from A? Well, in this case, the displacement will be 0 because I ultimately went back at A. So the final distance minus the initial distance will give you displacement, which is why, at the very end, everything touches back at 0 because it's 0 meters from her house. But that's just a side note. Let's get back to the main question. We know that she drove at 45 miles per hour, but we're trying to graph it with distance. So how can we relate distance and time with velocity? Well, d is equal to v times t. This is a formula that everyone should know when you approach AMC and physics in general. So the distance traveled, we don't know. The distance will be equal to the velocity, well, it's 45 miles per hour, times the amount of time that she, traveled at this velocity. So the correct answer would be from 8 a.m. all the way until 10 a.m. That's 2 hours times 2 hours. Now, the hours and hours cancel. We're left with 90 miles. So that means this point right here should correlate with a distance of 90. So let's cross the ones that are wrong. This correlates with somewhere nowhere near 90. This is way above. This is way below. And only we have A or E left to consider. Now let's consider the next critical point, which is this point right here. Now, at that point, we know that's the point where she stayed for 3 hours, because she hiked for 3 hours, right? So she never got further from her house when she was hiking. So when we want to consider that, that would mean that the space from this point to this point must be 3. Well, in this case, there's correctly of 3 spaces, and the same thing goes for graph E. So we must consider the last criteria, which is that she drove home at a constant speed of 60 miles per hour. So when she drove back at a constant speed of 60 miles per hour, one thing you should know is that for a distance versus time graph, so this is a distance and this is time, the slope of this line corresponds to velocity. Now, why is that? The velocity always has the units of a distance over a time. And we know that the slope, by definition, is change in y over change in x. Now, the units of y is distance, which is in some form of miles, and the time must be in some form of hours, which is why the slope must give you the velocity at that time. So basically what we're trying to say here is that which segment, this segment right here or this segment right here, gives a slope of 60. In this case, it would be negative 60 because it's going backwards. So in this case, let's calculate it because we have the 2 special points. We have first point is let's see, that would be so this is 1 p.m. So 1 p.m. is the same thing as 13 o'clock. So we can say that's 13, 90. And the next one is at 3 o'clock. Well, 3 o'clock is the same thing as 15, 0. So change in y will be negative 90, change in x will be 2. In this case, we get negative 45, which is not the same as 60. So therefore, by process of elimination, the answer must be choice E.